All right, hi folks, this is Larry Mussolino. I wanted to record a video here for Module 2 homework in my labs and help you get started. And an important topic here in Module 2 is going to be working with limits. And so let's do a few examples of calculating limits using tables, and then we'll look at limits using graphs. So let's start out here with the first question. It says they're giving us a function g of x, and they're telling us it's 6 square root of x. All right, let's go to part A. It says, what is the average rate of change over the interval 1 to 2? Well, when you see average rate of change mentioned, really they're asking you for a slope calculation. And you remember the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, this is the slope of a straight line. So they're asking us to connect these x values with a straight line. Let's think about this graphically. So this graph does something like this, right? It's the square root function. And let's say here is x equal 1, and let's say here is x equal 2. So let me mark these points on the graph. When they say average rate of change, they're asking you to imagine a straight line connecting these 2 points. And they're asking you to find the slope of that straight line. They're not asking you to find the slope of the red curve. Average rate of change means to find the slope of the straight line. Well, all we need are two xy points. So let's figure out for x equal 1, the y value is going to be 6 times the square root of 1. Right, here's the y value, 6 square root of x. But of course, that's just 6. So 1 comma 6 is 1 point. Actually, let's label it right here, 1 comma 6. All right, now let's let x equal 2. So y is 6 square root of 2. Well, they're going to ask us to round our final answer to 6 decimal places. So I'm going to have to work this out to, I'm going to say let's do it to 7 or 8 decimal places to make sure we have enough accuracy. So when I do this on my calculator, I'm getting the answer 8.4852.814. All right, and so here's x1, y1, here's x2, y2. Let's plug into the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, the y sub 2 is this 8.4852.814 minus y sub 1, which is 6, over x sub 2 minus x sub 1, that's just 2 subtract 1. Well, when you work this out on your calculator, you'll get the answer 2.4852814. But they say round to 6 places, 6 decimal places. So my answer is going to be 2.485281. All right, well, the next part is the same calculation, except they want me to use the x values 1 and 1.5. All right, let's go to this part of the example, though, because this one's going to be a little trickier. It says, what if the interval is 1 comma 1 plus h? So so x1 is 1 and x2 is 1 plus h. All right, let's find y sub 1. Again, that's 6 square root of 1, which is 6. How about y sub 2? Well, this is going to be 6 times the square root of 1 plus h. All right, again, they're asking me about average rate of change here, which means find the slope of the straight line. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Our y sub 2 is 6 square root 1 plus h. Subtract y sub 1, which is a 6, over x sub 2 minus x sub 1. So it's 1 plus h, subtract 1. Well, I really can't do anything to simplify on the top of this fraction, so I'll leave that alone. But the bottom, I have 1 subtract 1 cancels, leaving me just an h. So here is the average rate of change between 1 and 1 plus h. Now what they're going to ask you to do is plug in different values for h, 0.1, 0.01, 0.001. You can see that h is getting smaller and smaller. They really want to show you what's happening as h goes to 0. Let's do one of these. So let's do this one right here. So h is 0.1. So let me take m equals 6 square root 1 plus h minus 6 over h. But we're letting h equal 0.1. This is going to be 6 times the square root of 1 plus 0.1. Subtract 6 over 0.1. And if you work this out on a calculator, again, they're going to say here round to, well, this one says round to 7 decimal places. So you got to be careful and follow these rounding instructions carefully. But if you work this out on your calculator, you should get the answer 2.928539. Okay, and you'll repeat that for each one of these different h values. Again, you might want to use Excel to automate this, or you can write a small computer program to do this. All right, and they're asking you, what does the table indicate the rate of changes at x equal 1? Really what they're asking you to do here is look at what's happening as h is getting closer and closer to 0. Well, if I look at these numbers, I'm starting out with 2.92, 2.99, 2.999, and I'm ending up with 2.999999, etc. Well, that number is very close to 3. We call that number the limit. So as h approaches 0, which is the calculations you're doing here, the average rate of change is going to be called this is going to be the limit as h approaches 0, which is going to end up translating into what's called a derivative. And so they want you to just kind of conclude that the answer to parts C and D are the same answer. So this example is numerically intensive. Again, I suggest using some kind of technology for this, like Excel or a computer program of some kind, to make things a little more efficient. All right, folks, let me do a few examples here of evaluating limits when you're given a graph. And before I do this example, let me give you a little bit of background. What is a limit anyway when it comes to a graphical perspective? Well, you're going to be asked to find the limit as x approaches a certain value, I'll say c, of a function, and you're going to be asked for an answer. What a limit is really asking you is, as x gets closer and closer to the given x value, that's what that c number is, what is the y value getting closer to? So this answer that you're being asked for here is a y value of some kind. Now notice it doesn't say what happens when x equals c. It just says what happens as x gets closer and closer to that c value. What is y getting closer and closer to? Let me give you a quick example of what this might look like. Let's say I had a graph that did something like this. And let's say this is x equal 5. Now remember, when you see an empty circle on a graph, it means that the y value is not defined there. But the y value is defined. Let's say this y value here is 12, just to make something up. Well, this point on the graph might be something like, this blue dot here might be something like 4.99, 11.99. How about this red dot? This red dot might be 5.01, 11.98. All right, what if you're asked, what's the limit as x approaches 5 for this graph? Remember, the answer we want to come up with here is a y value answer. Now, what you have to do is really look at this from two sides. You've got to come in from the left side and the right side. So x is approaching 5. Remember, doesn't mean x equal 5. It's x getting closer and closer to 5. Well, I could be coming in from the left, and I could be letting x be 4.98, 4.99, and so on, getting closer and closer to 5. So as x approaches 5 from the left side, like I'm doing right now, what is the y value getting closer to? Well, I could see the y value is close to 12. It's 11.99. So the y value is approaching 12. Let me come in from the right side. If I come in from the right side, the x values are going to be like 5.01, 5.02. So as x approaches 5 from the right side, what are the y values getting closer to? Well, I can see the y value is 11.98. The y value is getting closer to 12. So it looks like as x is approaching 5 from both the left side and the right side, the y value is approaching 12. That is the answer for this limit. The y value is approaching 12. Now, very important, what you have to assure yourself is you have to ensure that this y value matches when you take this left-sided approach versus the right-sided approach. So when you come in from the left side versus the right side, you must get the same answer for y. If you don't get the same answer for y here, then we say the limit does not exist. Let me give you an example of what that might look like. Let me do a quick example of that. Let's say I have a graph that does something like this. It's going uphill here, and then it kind of does a jump like this. And let's say this is x equal 4. And let's say this y value here is 7, and this y value up here is 10, let's say. All right, how about if you're asked, what is the limit as x approaches 4 for this function? Remember, the answer we're coming up with has got to be a y value answer. All right, let me approach from the left. So I'm going to let x approach 4, but I'm coming in from the left side. If I do that, I'm going to be coming in from this left side like 3.98, 3.99, and so on. So let me just put a point here as an example. This red dot might be something like 3.99, comma 6.99. You might say, where am I getting these numbers from? Well, I know I want to let the x value get close to 4. And I know I want to let the y value get close to 7. But I'm not going to let x equal 4. So as x approaches 4, it looks like the y value is approaching 7. All right, let me come in from the right side now. If I come in from the right side, then x is going to be numbers like 4.02, 4.01, etc. Well, that means I'm coming down this part of the curve. Let me mark this green dot here. That green dot might be something like 4.01, comma. Now it's going to be a little above 10. I'm going to write as 10.01. So as I approach x approaching 4 from the right side, it looks like the y value is approaching 10. Do you notice these two y values are different? When you get different y values like that, we say D and E does not exist. The limit here does not exist. Okay? All right, well, with that background, let's go do an example here. It says graph this function and then find these limits and find the limit as x approaches -3. Now, if you notice here in part B, they say find the limit as x approaches -3, and there's a little subtraction, negative sign up there. When there's a little negative sign like that, we call this the left-sided limit. So you're coming in from the left side. So you would be letting x approach -3 coming in from the left side. Then it's going to ask you find the limit as x approaches -3, and then there's a little plus sign up here as a superscript. This is a right-sided limit. So you're going to be approaching -3 coming in from the right side. All right, first let's figure out the graph. So they want me to graph x squared. I know that graph is a parabola, but I can't let x equal -3. So at x equal -3, I'm going to have to put a open circle like this. What about when x does equal -3? They're telling me to make the y value -5. Well, that means there's going to be a solid dot down here. The solid dot is -3, -5. So on the graph, I have to have an empty circle. And down here, I have to have a solid circle. And I know this graph is wrong because they're putting a solid circle at x equal 3 on the graph. This is wrong because they're putting an empty circle down here. And this graph is wrong because there's a solid circle there. So it's got to be graph A. All right, now, when you're working in MyLab, sometimes these graphs are small and hard to read. But if you press this zoom in button, this plus sign here, it will zoom in and make the graph much bigger. Let's do that. All right, the graph is a little bigger. Actually, I guess if you press this pop-out window here, this pop-out icon, the graph is bigger still. All right, let's do part B. It says find the limit as x approaches -3, and it has this little negative sign as a superscript. That means left-sided limit. All right, well, here is -3. It's a little hard to see, but this is -3. I'm coming in this direction from the left side. Well, that means I'm kind of moving down the curve according to these green dots. Let me label one of these green dots just to make it a little easier to see what's happening. Well, I'm going to label that the x value is -3.01. And what about the y value? The y value here, I think this is 9. So the y value here is 9.01. All right. So as we're coming in from the left side, as the x value is getting closer and closer to 3, it looks like the y value is going to get closer and closer to 9. You know, if you imagine the y values of these green dots, they're getting closer and closer to 9. So the answer here is 9. All right, let's come in from the right side. So now they're asking us, what's the limit as x approaches -3 with a little plus sign here? That means a right-sided limit. So that means I'm going to be coming in, getting closer to -3 from the right side. All right, let me mark some points here to reflect that, these red points. All right, let me label one of these red points here. This is going to be -2.99, comma, 8.99. Well, as x approaches -3 from the right side, it looks like the y value is still getting closer and closer to 9. So this answer here is 9. I forgot to put f of x up here. All right, last part, part C. They're going to ask me to find the limit as x approaches -3. Well, to answer that, I've got to compare the left-sided answer with the right-sided answer. If these answers are the same, which they are here, that is the answer for the two-sided limit. If these two y values were different, let's say this was 9, but this was 7. If those two y values don't match, the answer would be D and E, does not exist. Okay, and so MyLab will ask you, does the limit exist, yes or no? All right, let's do one or two more examples like this to get a little more practice on this graphing aspect. So let me go get another example like this. All right, let's do another example here that is a graphical example for limits. And again, I'm going to make this graph bigger to make it easier for us to work with. All right, let me go to part A. Part A says, what's the limit as x approaches 4 for this graph? All right, well, here is x approaching 4. Let me do a left-sided limit to begin with. So from the left side, I want to know what is the y value approaching. And then from the right side, I also want to know what is the y value approaching, again, as x approaches 4. Well, if I come in from the left side, I'm going to be moving up the curve according to these red dots. So let me label this red dot just to give myself an example here. That red dot might be something like 3.99 comma. The y value here, this is -1. So it's getting closer to -1. I'll say -1.01. So it looks like when I come in from the left side, the y value is approaching -1. All right, let me come in from the right side. If I come in from the right side, then I'm going to be moving down the curve according to these green dots. Let me pick this green dot here as an example. That's 4.01 comma -0.99. And you might say, where am I coming up with these xy coordinates? Well, I'm just estimating them based on the location for these points on the graph. And I just want x to be a number close to 4, and I want y to be a number close to -1, because I can see that's where these points are converging to. Well, it looks like the y value is approaching -1 here. Because these answers are the same coming in from the left side versus the right side, that's the answer for the two-sided. Okay. All right, let's go to part B. Let me erase some of this stuff. Let's go to part B. It says, what's the limit as x approaches -3 with a little plus sign there? Well, the plus sign means a right-sided limit. So I'm going to be approaching -3. Here's -3, but I'm coming in from the right side. Well, in that case, I'm going to be moving along the curve according to these green dots. So let me label this green dot right here as an example. That would be -2.99 comma. Looks like I'm getting closer and closer to -4, so I'm going to say -3.99 for the y value. So as x approaches -3, it looks like the y value is approaching -4. So this answer here, this is f of x, this answer is -4. All right, let's go to part C. Part C says, what's the limit as x approaches -3 coming in from the left side? So this is a left-sided limit. Well, if I'm approaching -3 from the left, I'm coming in this direction. That would put me walking up the curve according to these blue dots. All right, let me label this blue dot here for a little example. The x value is -3.01. What about the y value? It looks like the y value is going to be 2.99. Again, I'm just estimating it based on the location of that point. So as I come in from the left side, it looks like the y value is getting closer and closer to 3. So the answer here is 3. All right, let's go to part D. It says, what's the limit as x approaches -3? Well, the limit as x approaches, so we're doing part D now. The limit as x approaches -3, I have to compare the left-sided limit answers with the right-sided answers. If the answers are different, like they are here, I have a -4 coming in from the right side and a 3 coming in from the left side, these don't match. Well, if they don't match, your conclusion is the limit does not exist. So this limit does not exist. All right, well, let's do one more example where we do a limit calculation algebraically. So let me go find an example of that. All right, let's do an example here where they're asking you to find a limit, and they give you the function algebraically. All right, well, if you evaluate a limit for a continuous function, so let's say I have a continuous function here. Continuous function means the graph is a smooth graph with no gaps or jumps. Well, if I was to find a limit, let's say here at x, x approaching 7. Well, if it's a smooth curve with no gaps or jumps, the limit here is going to end up equaling the y value. Because if you were to approach from the left versus the right, you would still end up getting closer and closer to a y value of 10, which is the same as the value of the function itself. So if you take the limit as x approaches 7 of this function that's continuous, the answer is just going to be the y value itself. All right, how about if we try that in this example, though? I'm going to let x equal -2 in this function. I just want to see what happens. If x equals, I'm going to let x equal -2. All right, well, this is going to end up being -6 times -2 subtract 12 over -2 to the third plus 2 times -2 squared. All right, let's see. On the top, we have 12, subtract 12. But on the bottom, we have -8 plus +8, right? Because this is 2 times 4. But -8 plus 8 is 0 on the bottom. We can't divide by 0. So doing a direct substitution here is not going to work. Let me give you another example just to show you that you could do direct substitution if the function is continuous and you don't end up dividing by 0. Let's do limit as x approaches 5 of 10x minus 3. I could just do direct substitution here and replace x with 5. And this would be 50 subtract 3 equals 47. But I can't do that here because we're ending up in a division by 0 problem. But here's an alternate strategy I can use here. What if I was to do a little bit of algebra work? And what if I was to factor the top, factor the bottom, and see if an expression might cancel out? And if it cancels out, maybe I could use that direct substitution method and not result in division by 0. Let's try that and see what happens. All right, I'm going to take the top, and I'm noticing on the top I could factor out a -6. So I'm going to take a -6 out on top. That's going to leave me x plus 2. On the bottom, I think I could factor out an x squared. So let me factor out x squared. Let me write the limit in front here. If I factor out x squared, I'm left with x plus 2. Well, it looks like it's my lucky day because I do see that I can cancel out this x plus 2 top and bottom. So I'm left now with the limit as x approaches -2 of -6 over x squared. Now I can use direct substitution because I don't have an issue anymore with dividing by 0. So if I do direct substitution, it's going to be -6 over -2 squared. That's -6 over 4. My lab says simplify your answer, so we got to simplify the fraction. -3 over 2 is the limit on this one. All right, hope this is helpful to get you started here in the Module 2 homework dealing with different kinds of limit type evaluations.